Cool. So as always, feel free to interrupt me. I'll try not to get too off topic. But if you have questions, something doesn't make sense, pop it in the chat, unmute, you know the drill at this point. What we're aiming to talk about today really is how do you keep a good track record of what you're doing? How do you create something that makes sense and really links together the code that you're writing with the figures that you're producing? Because this is the way that science is going, and you have good reproducibility in your code. And then when you create these documents, how do you then include things like session information? I do have a question from, I'm not sure how to pronounce your name, but Zhuhang, maybe. Can we watch the recording later? And if so, how can we access it? So we're just figuring out the recordings at the moment. I haven't had, with all the teaching, I haven't had much time to finalize that, but I'm going to try out some options, hopefully at the later end of this week, for how to host it. Last time we hosted everything on Box and it worked fairly well. However, the streaming software on Box is a little clunky. So we're going to try out some other options, and we have some ideas for that. And as soon as we get it up, we will let you know, and then you'll be able to watch everything back and review what we covered. Okay, so yeah, with the way everything's going, you need to be able to look back at a figure and say, okay, someone says, I installed Git and it still says Git version not found. If anyone's having troubles with Git, maybe we can talk about it after rMarkdown and Reproducible Reports. It might be that you need to restart your computer or something. Oh, someone's got trying to get the download of the file and they get a false at 404. That's interesting. Like this. Okay, mine's working fine. I don't know if you can see that, but it is downloading. So if maybe the link is broken in the slides, and I'll have to update the link. But if you come out, you can you do it here. Yeah, so this is the one you're talking about. Yeah, that one's broken, it seems. Okay, so I'll write a note to update that. Yeah, we did some updates to our structure, so maybe they got left behind. Okay, so yeah, so I'll tell you now for the next 45 minutes to an hour how you can make things reproducible, how you can link your code to the outputs, and then also what packages you used, because that's really important as well. Yeah, and so everything is accessible in much the same way. You just got to remember you download it, not that link, but the link on the main page, and then you can set your working directory to be our course. And so this is a quote that relates to reproducible research, and it's from 1984, but it's basically saying we want to change the attitude, the traditional attitude about how we construct programs, and instead of really focusing on how do we get the computer to do what we want, rather let's actually explain to humans what we want the computer to do. Okay, and so with this in mind, this is really giving you an idea of how do we explain the code, like once we get it working, and as we're making it, how do we get it so that it's actually readable to someone else, and how do we get it so it's readable to my future self as well? Because something may make sense in that moment, but it won't make sense later on. And that's a really big thing in science, right? It's the continuity. Unless you are a PI running a lab, at some point, there's a future person who will come in and replace you in the lab, and they need to be able to understand what you did. And likewise, if you want to ever collaborate with someone and actually share your code, and obviously collaboration is a really great thing, but if you want to be able to do that, they're going to have to be able to understand what logic you're using. And so using Rstudio makes this all very easy. And so the simplest way we can do this is you find, say you have an R script of interest, you add something called session info at the end, and then you click compile notebook function. So I could give you a quick demo of this. Let me quickly change what I'm sharing. Okay, so you can see this. I'm going to create a new R script. I'm going to do 1 + 1. This is my script. It's a 1. It's a very exciting script that does 1 + 1. Okay, and this is what session info. So this is a function. When I run this, it adds all of the information about my R into it and what packages I have and things like that. So then when I use compile notebook, okay, so that is up here, I believe. Oh, no. Oh, I haven't done it this way in a while, sorry. I've lost where compile notebook is. Oh, there it is. So if you go to File and you go to Compile Report or Knit Document, it will ask you to give it a name. So I'm just going to call this demo. I'm going to chuck it on my desktop. You might not be able to see what I'm doing right now, but I'm going to switch you to this. Okay, so I'm saving the file. And then I'm selecting a HTML output, but there's different options. And I press compile. And so what it does, it runs the code and it creates this report. And so it knows that I am at, it knows the date, and it's run my code. It has the result of my code, and it has all the session information. And so this is one HTML document with everything that I need to know about the script and how it was run. And if you imagine I do a plot and things like that, it will output the plots in here. So we could add a plot if you wanted. And this is going to be a very, very non-exciting plot. Again, we can compile report, compile. And we have a plot. It's all inbuilt. Okay. You can also, at this point, you can save the image, copy the image if you want to put it somewhere that isn't in here. But now, this is the nice thing, right? You have everything tied together. You have the code, you have your outputs, and you have the session information, which you need to be able to reproduce this. Okay, and so this is your first level idea of how to create a good notebook, how to create a good reproducible copy of what you're doing. And so with that, you've seen how quickly you can do it. You just go into the file, and you add it. You can also do it from within R. So we got a question from John Nicholas. When I click compile report, it says R code execution error. That is going to be hard to diagnose because it's quite an ambiguous error. My guess would be that there's something wrong with your R code itself. So try running the code without compiling first and then try compiling. My guess is that one of the pieces of code is not is broken in some way. Okay, so yeah, so you can see how quick it is, and Rstudio does this by using these two packages, rMarkdown and knit-r. Okay, and so the terminology that we're using is you're taking a document and you're knitting it together and making a HTML document, which is your report. And so with the rMarkdown, you can also start to render other scripts from within R. So if you have a script, you can use the function render, and that will run all of the script and turn it into a HTML from within R. Okay, so I can give me a sec, and I can demo that for you. Okay, I'm just loading up my tidyverse, or not my tidyverse, my reproducible R session. Okay, so let's do a new share. So you can see I just navigated to the right place for me. And now I'm going to load in our Markdown. And if I do dir, there's a scripts folder. If I do just scripts, you can see there's lots of different scripts in this scripts folder. And so there's one called script.r. So I'm going to apply the render function to it. It's going to compile. And now in that folder, if I have a look, okay, so we are here. If we go into scripts, next to .r, there is now a HTML which I just created. So I can click on it and I can say I want to view it in the web browser. And I will show it to you now. Okay, so this is the report that I just created. And so in this script, I can actually grab the script. I'm going to share my whole screen again. Okay, so this bit here is the script. And this bit here is what we rendered. Okay, so you can see how it went through piece by piece. It did the sampling, it did histograms, showed you the output in line. It did a t-test. You get the result. We drew a nice plot to show the difference with the summary of the information, and then we have session information. So you can imagine if you're doing a little piece of data analysis, maybe you have some qPCR results, you could easily do this analysis and wrap it up in a little report, and you'd have all the information there. You'd have the code you used, the data inputted, or at least you know where you read it in from, because you'd have read.table or whatever in the top. And you could then easily, because it's a HTML document, you could then give it to someone to look at, right? Because a HTML document will open up in any web browser. So you could pass this on to a PI or a colleague so that they can see the result. And so by default, it creates the HTML. It can also create PDFs and things like that, but generally the HTML is the best option. And that's controlled in the output format argument. You can also decide where you want to, what you want to call it with the output file option, or where you want to actually create it. So you can create it where it is, or you can create the resulting HTML file wherever you want. Okay, so that kind of shows you how quickly and easily you can take a script, you can use the script you're actively working on and turn it into a document. Or if you have a script already, you can run it from within R and render it with a bunch of different parameters that you can control. And so what we saw, like rendering this report with things like the author and the date of the render, it's really the first step in reproducibility. And code is great. The fact that you're showing the code is really useful, but it's not as useful as it could be because the code isn't annotated. And so what do I mean by annotation? The way I typically annotate code, and a lot of other people do, is what a lot of people do is they'll add a annotation to describe what the line is doing. Okay, so in this case we have the hash, or the pound sign, depending on what you want to call it. And what this does is it allows you to write some text after it, and it basically means ignore everything else in this line. Which means you then have some free-form text which can then describe what this is doing. So in this case, we have rnorm, which is a function which allows you to generate some random numbers. And so we can annotate it. This is me generating some random numbers. Okay, and so this allows you a basic form of like notation. And so you can start to explain step by step what you're trying to do. And we have another question from Zhuhang. Why can't I run the render function from the coding panel? So there could be a bunch of different reasons for that, Zhuhang, and I'm going to need a little bit more information. So what does it say when you try and run render? That's always, we need to know the error message before we can diagnose why it's not working, because it could be a bunch of different reasons. Okay, so it can't find the file that you're trying to render, right? So the file scripts does not exist. So normally the error messages contain a lot of information about why something's not working. So if it can't find that, but it works in the console. Oh, so I see the issue. Yes. So okay, so it works in the console, but not in the, what do you mean by the coding panel, I guess? The top left-hand panel? Okay. And are you using this, I guess, the document, is it a R script? Or is it an rMarkdown script? It is the R script. Okay. From the coding panel. Okay, I'm not sure, if I'm perfectly honest, I understand your setup. Yeah, so, yeah, so we have a question for those that are not in the chat. Zhuhang is having trouble with his directories. And so you've set the working directory as instructed. So that means the console is working fine. And so you have some of the information typed into your coding panel in the top left, and you're trying to run it from there. Are you using the green arrow to run? Okay. Command and enter. Okay, so you're using the shortcuts. Good job. And so one thing you're running to, so you're trying to run this. Sometimes, depending on the document type, the working directory in the top left-hand panel is different to the one in the console. And this is because this is normally if you have a project set up, and it considers everything from the viewpoint of a project. So I don't know if you're doing that, but it might be that I have to just have a look at your system, but I might not be able to do that right now. I'll have to wait till afterwards, if that's okay. Let me just quickly check. Yeah. But what you can do if you're having trouble is when you're writing it in, you can have a look. So I'll show you. Let me quickly show you something, a little trick. So say I wanted to render something here. And you can press the tab key, and that brings up all your options. So that tells you from where you are, what can it access. So I could look for a script in here. And then you can, once you do that, you can press the tab and it comes up with more options. So that should tell you where the script is relative to, where this is relative to everything else. And so that should help you find the correct path. It's a good lesson for everyone. Tab is super useful for completing things. Okay. Right. So we're into comments. So the hash or the pound is a super useful way of just saying this is some free-form text that I want to have, and it doesn't get evaluated. So if you want that text to actually be included as real text in your report, you have to add an apostrophe here. And so what do I mean by real text? Okay, so when you create your report, anything that has this pound sign is included in the code chunk. So if I look again at this one, so the code chunk is this. So anything with the pound sign would appear in the same kind of text setup here. But anything that has the apostrophe would appear outside of this as text. And it would be formatted slightly different. It's normally a little bigger. So this is nice if you want to say, if you want to have like a header or something like that, or something that's a bit clearer about a clearer documentation about what the code chunk is doing as a whole. If you want to control the things like the author, the title, and the date, you can also add that metadata in. And so that is controlled with something called a YAML. And so YAML is basically a config file format, but you can just add that onto your document. And so here you still use the apostrophe, but you then use these 3 hyphens as a little page break. And then you can put in your metadata here. So title, author, and the date. Okay. In this case, we put in the date with adding in extra information. So a lot of these things that you fill in, they have an idea of what you want to put in them, but there's no actual like formatting restrictions. So quite often people will want a title, then the author and the date, and there's a nice hierarchy in the formatting. So it appears like the title's really big and then the author's under that with a nice date. But you can use this instead as a subtitle if you want. But we'll come back a little bit to YAMLs in a little bit when we talk about rMarkdown. You can also control the way things are evaluated using these modifications. So if you use the pound sign and a plus, you can add arguments that control how the subsequent code chunk is evaluated. So it has to be in the preceding line, but we can see here, we can actually control what the size of the figure is going to be when you make this histogram. And so there's lots of different options for controlling how the code works. And so this is just touching on some of them, but we'll touch on some more as we go through this. Okay, so there's an example exercise, but we're not going to go over that right now in the interest of time. But if you go through the exercises, you'll be able to see it walks you through doing some of these scripts and then converting them via rendering, and you'll be able to see how that affects the outputs. So now we're going to talk about Markdown. Okay, so this isn't rMarkdown, this is regular Markdown. So what happens when you're making these documents like this? Under the hood, R is converting this into a document that's called a Markdown format. Markdown is known as a markup language, and it contains a mixture of plain text and some other formatting syntax that allows you to convert it to very rich text document types. Okay, and so what we mean by that is you can have these very simple text documents with Markdown, but it will convert it into something that's the HTML that's stylized and formatted and has these like nice separation between regular text and then your code chunks and then everything else. And then once it's been converted to Markdown, Markdown can then be rendered into things like HTML, PDF, or Word documents. And so that's this Markdown is a stepping stone that R uses on its way to making the HTML document for you. It's also really useful to kind of understand how Markdown works, because as we use later, right, we're going to talk about GitHub. GitHub can actually directly interpret things like Markdown documents and render them as web pages for you. And so they have guides on using Markdown because they're used so frequently. Okay, so you can look through here and it will talk about using Markdown here. Okay, but they have a specific form of Markdown that they use. So I've been talking about Markdown a lot, but you don't necessarily know what it is yet. And so it uses this simple syntax to control your text output. It allows you to include font styles, text structures. You separate images and code chunks, which we got a taste of when we just did it through the render method. And so we can have a look at some of the syntax for this. And so because it's plain text, it ignores new lines. And so when you're writing just text out, you have to delineate the fact that you want a new line by leaving 2 spaces at the end of your line. Okay, so in this case, you'd have this, by leaving these 2 spaces, this would be put onto a new line. But if with this one, because there's no space in between, this would actually be up here next to it. And then if you want to start a new paragraph, you have to leave a line of space in between. Okay, so you can see here there's some nuance with using it. But basically what we're doing with this is if you're working with a Markdown document, it allows you to add more complicated formatting to something that you could then turn into a report. You can add emphasis with the asterisk or the underscore. So if you use one of them to border some words, you get italicized, or if you use 2 of them, you get bold. Okay, and it looks like this. You can add images super easily, and that can be from a HTTP address, or it can be related to a nearby. So you use this nomenclature. You have an exclamation mark, square brackets. You can have a name for the image, or you leave it as alt text. And then you have where the image is. Or you can just put in the web address. Okay, and then you can start to actually create hierarchy in your document by using these pound signs. Okay, so this is an important delineation. So when R starts to render your document, it converts it to Markdown. At that point, all the pound signs you're using for commenting are converted to something else. And the pound signs, when you're working on a Markdown document directly, have a different meaning. And I'll show you this in its totality in a sec once we get to code chunks. But when you're working on a Markdown document directly, you can see that if you have one pound sign or one hash, this is considered to be a top level header. If you have two, this is like a middle level header. And if you have three, it's a bottom level header. And so this controls the size of things like these headers here. So this is what it will be rendered to. Okay, so this is a little abstract at the moment. But I'll show you a few more formatting things, and then we'll show you in action a little bit more. So you can also add lists quite simply using the minus or the plus symbol, or minus with the plus symbol. Okay, and so the minus shows you a list which gets rendered into bullet points. Okay, so this is the Markdown input, and this is what it renders to. And the plus indicates a nested list. Okay, and so this is what it gets rendered to. You can also use ordered numbers in much the same way. So here we do 1 point space, and then we write our item. Okay, and so the important thing is, like, you can have all these free-form text, you can have all this annotation and description of what you're doing in your project. You can use things like this to say, my aims for this piece of analysis is to find the average counts per gene, to calculate the TPMs, and to draw a box plot of the differences or something like that. And so then you can write that as your goal in your report. And then you're obviously going to need some code. And so the code is delineated when it's in a Markdown by the apostrophes. Okay, so you have 3 apostrophes, then you'll have code, then you'll have 3 apostrophes to close the code. And so this is what this would end up being rendered to. Okay, so you have your 3 things. This would be a code chunk, but then you can also have some text above it to describe what you're doing. It's also easy to add links to these. So this is nice when you say, I use this methodology, and you can point to a paper or something like that. And so this is similar to inserting an image, you just don't have the exclamation mark at the front. And the text in the square brackets will become the actual text of the link. Okay, and then we have page breaks, which can be specified with dashes or 3 or more asterisks. Okay, so that's kind of like the basics of formatting with Markdown. It's pretty dry. But the key thing I want you to get from this is that instead of just coding in an R script where you just have a bunch of R code, if you code within something that is Markdown or Markdown related, you can then just write whatever you want to write. You can describe things, and you follow these formatting guides to then structure it in the way that you want to. And then you'll carve out specific regions where you're like, this is the code that I'm executing. And so these will be the regions that have the triple apostrophe. Okay. And so I've kind of just introduced you to the general flavor of Markdown. Okay. And it's very commonly used. But in Rstudio, there's a very specialized version of Markdown, which is called rMarkdown. Okay, and so this is a .rmd file. And the nice thing about it is it's focused on our code, but it allows the inclusion of all that syntax, the Markdown syntax that we just discussed. And so with this, you can get all that integration we saw in the reports, but you have much better control over like the documentation. It's much easier to write notes associated with it. Okay, we have a question. So what's the difference of writing your script in an R notebook versus in an R Markdown file? So an R notebook and R Markdown are very similar. They use a lot of the same methodologies under the hood. The big thing with R notebook is, so I can just show you, let's go to here. With R notebook, when you do this, you create an R notebook. When you save it, you don't have to execute all the code. So I could save this as an R Markdown here, okay? With an R Markdown document itself, so the other option is R Markdown, you actually start creating some of these information that's going to go into it. So let's say this is going to be my RMD demo, and it's mapped. So it allows you to start creating some of the attributes associated with it from the get-go. So you have like this. You can see how the YAML's updated. You also have some of these setup options. These are something you can dig into later when you get more comfortable with R Markdown. Yeah. So those are the kind of like it's some like very small minor details, but it's also in the way it knits is slightly different. So we can preview this, and then it forces you to save. And it will render it in much the same way. Okay, I'm just rendering them real quick. And so when you, let me just share it. When you save your document, it forces it to render and it will appear in your screen. It will pop up and it'll be like, this is my rendered document. I rendered it for you. And this is from R Markdown. Okay. With a notebook, it doesn't do that. So really what I'm getting to is the notebook is a slightly less rigorous version. Okay. And so I'm trying to find out where the notebook is so I could show it to you. So it's created a slightly different version of the HTML. It's a notebook HTML. And you are in our course. Here it is. So it looks very similar. So it rendered pretty much the same document. Okay, but there's just some different defaults that are used within a notebook compared to a rMarkdown document. And an rMarkdown document just has more control, I'd say. Okay. Yeah, so rMarkdown essentially, it has a little bit more control, and it has some slightly different defaults that will actually generally make the document you produce a little bit more rigorous. So I would always pick an rMarkdown over a notebook when you're starting a project. Okay, so as I mentioned before, knitr is one of the main packages used for this rendering, and it's what's really the main route to create and manage these rMarkdown documents. And so this was created by Yi Hui, and he has a fantastic overview of how they work, the different options available, and things like that. He is a very, very prolific coder who's very, very active. And so there's lots of options here that you can look into. And so once you kind of, like we talked through Markdown a little bit, the only real difference between Markdown and rMarkdown that you're going to have to note is the code chunk itself. Instead of it just being 3 apostrophes like this, you'll add in a curly bracket and you'll specify that you want to use the R engine. Okay, and so this is the really nice thing about the Rstudio integration, is that you can actually, Rstudio is not just for R, you can also execute Python and shell scripts. And so through in your Markdown, you can change which engine you're using here. You can write some Python code, and you can also have some shell code, and it'll all execute together depending on which engine you use for that code chunk. And so you can see here, this is an example of what I might put in a Markdown document, right? And so I have some description of what I'm doing. So this would actually say I am making a histogram of some numbers that I really care about. And then I have a code chunk that's actually doing the coding part of that. And then when it renders, it would look like this. And it's all together, and it's all tied together. So you have your input and your output and your description. Also within these curly brackets, you can also include arguments, okay? And so if we remember right at the beginning, when you have an R script and you want to annotate it and then render it, you can add a £sign and an apostrophe, and that will be interpreted as a parameter you're passing to that code chunk. But here, what you can also do, once it's an actual rMarkdown, it's much easier to understand how this works, because you just add it to the code chunk header itself. So here, we're adding a parameter called eval, which stands for evaluate, and we say we don't actually want to evaluate it. And so that means you can have code in your Markdown document that doesn't actually get evaluated when it turns into a HTML. You can switch it on and off. And so this can also sometimes be useful if you want to demo some code, but you don't actually want it to evaluate when you make the Markdown. And so in this case, you can see here, it echoes the code back to you, but it isn't making the histogram. Likewise, you can do the opposite. If you want to keep your code secret, or if you want to create a report that is very visual, okay, you can do this. Echo equals false. And so then the code is not shown, but you'll get the result out. So using these kind of arguments, you can then start to build a document that looks very visually appealing. It's very easy for the reader who's not you to understand it. And it's a nice report that displays your analysis. You can also, there's other parameters. Warning and message is a common one. Quite often when you load in a library, it will add a bunch of text onto your screen and your console. You can just turn that off by removing with warning and message equals false. So that any warnings you get and any messages you get will not be displayed. And as we saw before, you can control figure width and things like that. And so you can control that also within this code chunk. Sorry. Another really nice option is the tidy option. Okay, and what this does is it isn't the same as what we were doing this morning with the tidyverse, but what it does is it tidies up your code a little bit. And so you can see here in this code chunk, it looks like a bit of a mess. There's all these returned lines. There's all these gaps. And what it will do is it will tidy up the code so it looks nice and straightforward. And so what happens normally is your your code will be output into a code chunk. And so that's what I was showing you earlier. Do I have one of these open? Yeah, let's show you this. Okay, so what I mean by a code chunk is the code is kept in one of these chunks that looks like this. Then the output of this would appear beneath it. Okay. What you can do is use the argument collapse equals true, and that will actually include this within your code chunk, so it's all kept together. Sometimes people prefer the outputs if it's like these numbers to be right next to the code itself, but this is just a formatting thing. A big one that's really nice for these documents is to use the cable function. So cable is the knitr table function. And so the way it will work is, say you have a data frame. We've created a data frame here. So you surround it in cable. Okay. And the code will look like this when it's put into Markdown. And it will make you a nice table. And so what I'm hoping you're being able to see now is that you can start to build together a collection of plots and a collection of tables, a collection of all your data in a step-by-step way with all the free-form text that you want in between to explain what you're doing. You can hide some of the code, or you can keep the code depending on what the audience is for the format, for the report you're making. And it might be an easier way and a much more reproducible way of sharing your results with someone, instead of, say, if you're having a meeting, creating a PowerPoint and then having to copy and paste all these different figures into place. And then they may ask you, how did you do this? And then you're going to have to look at your code separately and remember, well, this will all be in one place. Another really nice trick is when you have this free-form text that's describing what you're doing, sometimes you will actually want to say, oh, you want to use the data itself to grab a number. Say you want to say, I have 230 significant genes. And instead of having to write that out, you can get R to double check what's going on in your data set and then get the number for you. And so that means if you change anything, like you change how you're calling significant genes, it will dynamically update the report. So in this case, we have some text. We have some text, and it now says the first result from an R norm call is this. Okay, and so now this is the syntax to then talk to R and ask what's going on with these objects. So in this case, it's going to, you have to have an apostrophe, then you have an R, and now it's everything after this is evaluating code. So in this case, it's going to look into the R norm object and it's going to grab the first object out, the first entry. And so you can see how this is evaluated, where it's saying, here is some freeform markdown. We've added some italics. And the first result from our norm call is, and it gives you the actual number. And so this is a nice way to embed results from actual R code evaluations inside freeform text. Okay. Sometimes you want to evaluate something that is very intensive computationally. And often when I'm making these documents, I make them and then I make some updates and then I re-render them and then I make some updates and then I re-render them. And if you have a chunk that's taking a long time to do anything, what you can do is cache it. And when you cache it, it will then, the first time, it will save the results of that chunk, and then it won't have to run that chunk again. It will just use the cache you have saved, although this will use up your memory. Okay, and so we talked a lot about plotting yesterday, and we looked at some of these, like I showed you a document earlier, right? Like this one. And you can right click and save it. But this is still, it's not super tight. If you save this, you then have to like name it. You're going to save it somewhere and then maybe you forget where it's coming from. But what you can do is actually encode in your Markdown that not only are you going to produce the plot in your Markdown report that you're making, you can also get it to save somewhere as well for you. So this is something I typically do is, I'll have my R code chunk. I'm saying I'm doing R. I want this chunk to be called this, and this will be used as my plot title. I have some attributes that I pass to the plotting. Then you say, this is where I want to save my figure. And then you specify what format you want. And quite often I want both a PNG and a PDF, because PNGs are really nice to put into PowerPoint, and PDFs are really nice if you ever want to make your final paper or do any edits. So I often make both. And then it will do this plot, and then you'll find that the image of this plot will be saved within the figures folder. It will have this name, and there'll be two of them. One will be a PNG and one will be a PDF. And so that means in your code, this plot that you just made is directly linked to its output. And hopefully based on its name and the fact it's in this directory associated with your report, you'll be able to figure out which code it came from as well. Okay, so we're nearly there. At the top of your R Markdown, it has lots of options. And so you'll recognize these as the YAML from earlier that you can include in just a regular R script if you want. And so included a title, author, date, and the type of output. And so if we look at my R screen here, you can see that a lot of these are automatically populated when you create an R Markdown document. But I can just edit them and update them if I want. So I can just actually, I want this name. And that will be the name of the document when you render it. There's lots of other things you can add to the YAML as well. You can change what type of output it is, quite simply. You want to convert your R Markdown to a regular Markdown. Maybe you want a PDF. You can also add some variables to it so that they become the global default options. So a couple of slides ago, I showed you how you control a specific figure. So this will only affect the parameters and properties for this single code chunk. But if I want all the figures to be a certain width and height, you can control it at the top. And you can also start to control formatting in this way as well. So there's lots of different document format options. And it can make your document look quite nice and professional looking. So it's in this section. I think it's lower down. Yeah, so there's lots of different options here. These are all the different options. Okay. But there's also more that you can install. And so you can play around with these, try out different ones, see which ones you like the look of. You can also, if anyone's familiar with CSS, you can add a custom CSS document as well. So I'm going to quickly show you this in rMarkdown. We're pretty much at 2, so I'm just going to, I've been kind of demoing as we go, but I might show you some of these YAML options real quick. So maybe I add in theme. Okay, and so we have all this text. Let's say this is a demo. I am demoing some stuff here. So I just did a double space, and this Markdown is great. Cool. And then we can add some other bits here. Our norm goes to A. A place 1 is equal to okay, so I'm going to show you just a couple things here. And then the other thing that you'll pretty much always want to add in the end is session information. Okay, so hopefully this will demo some things. I've added in a theme, so it'll make it look nice. I have some different header information, so you can see what subtitling looks like. I had a couple spaces here, but no space here. I define an object here in this code chunk, and then I'm going to output it here in the code chunk, but I'm also going to put it inside the code here. Okay, so we can just knit this. Oh, of course, it's not going to work. Oh, I see the issue. Sorry, I had the wrong format here. That should work. There we go. So it rendered. And it's this. So you can see how the formatting's changed a little bit now. We have these different text options. You can see this is a demo. And then I have a subheading for this is a demo too. This is where I put 2 spaces, but I didn't put a space here. I did my summary for cars. I defined A. And I look at what A1 is, and then I embed what A1 is here in the actual text. And then I can have my session information at the end, and this shows me all the packages I've been using to produce this document. You can also see there's a nice table of contents on the side. You can add things like this as you go. Okay, so that is pretty much rMarkdown. Let me just put this back over here. There's lots of links to, this is like a whole can of worms which you can dig into, but on the start of it, I just encourage you, whenever you are doing a piece of analysis, just go to your Rstudio and start your project as an rMarkdown instead of an R script. And it means you can really annotate as you go. There are some exercises here, but I'm just going to put up a quick poll to see how everyone did with it. Okay, and then we'll come back a little bit later at 3 to go over Git and GitHub. And so that's the last part of reproducibility that we'll cover, and it's really important for working collaboratively and working in a very controlled way. Okay, we have a question in the chat. Okay, that's just thank you. Thank you. Thanks for coming. Okay, of course, if anyone has any questions, I know this section, it's hard to demonstrate to you the usefulness of rMarkdown until you actually do it. But hopefully I've persuaded at least some of you to give it a try. Okay, I'm going to give it another 20 seconds and then I'll close the poll. Okay, we'll just close it there. So I think everyone got the fact that pound signs indicates your headers. And I think I may have tricked some people because I included 3 trues and I typically do 2 trues and 2 falses. But yep, if you do exclamation mark, square brackets, alt text, and parentheses, you can embed in an image that way as long as you add the directory and the path to where that image is. If you got rid of the exclamation mark, that would be for a link. It is not the same as HTML. rMarkdown is able to be turned into HTML by rendering. And so what you'll really want to be doing is making these HTML reports, but rMarkdown is what you'll be working on to generate this. And yes, the YAML section controls the properties of the rMarkdown, although you can directly control the properties of each code chunk if you want, using its little header within the curly brackets. Cool. So that will be us for the moment. We will reconvene in just under an hour to talk about GitHub.